change of sign goes along with the critical points idea. Because when you talk about a function, when will it change from positive to negative? And it will happen in one of two situations. Obviously, at the x-intercepts, because when it's 0, that must be the point where it could possibly change from positive and negative. But the only other situation is maybe at a discontinuity, because it could always jump from positive to negative at a discontinuity. I guess the classic examples are y equals 1 on x. See, on the left-hand side of the axis, it's negative. You get the discontinuity, but bang, then it jumps to positive on the other side. So it's those two situations. So when we talk about an inequation, it is actually a method I showed you yesterday on the board quickly, but let's look at it in a bit more detail. We can use this idea to solve an inequation. So first of all, one like this. If I've got x minus 1 squared outside of x plus 3 is less than or equal to 0. I can draw myself up a quick sketch. It doesn't have to be accurate. All I really need to be accurate is the x-intercepts and where is it positive, where is it negative. So I can draw something like that. I don't really care where the vertex is and things like that. I know it's got that sort of shape. Because just like the quadratic inequality, I'm just saying to myself, when is this curve less than or equal to 0? And so I can read off the graph, well, there's the 2 points where it's equal to 0, and the only other time is on the left-hand side of negative 3. So the solution to this would be x is less than or equal to negative 3, or the single point of x equals 1 would be another possibility. Going back to our pronumeral in the denominator type question then. So what I can do with that one is move the 5 to the left-hand side and then create a single fraction. We get minus 13 minus 5x over x plus 3 is less than 0. So again, using the critical point idea, we're saying, when will this change sign? Well, it only changes sign in two situations. When it's equal to 0, which must be when the top of the fraction is equal to 0, or when there's a discontinuity, which would be when the bottom of the fraction is equal to 0. So we look at those two things. There's the zeros, x equals minus 13 on 5, and the discontinuity is x equals minus 3. We've come up with those critical points that we like to see. And then we can test like we did before, and we see, oh yeah, we're on the outside for this one. So we get x is less than negative 3, or x is greater than minus 13 on 5.